Let's try tutorial question 2. Place a transfer function from example 2 into Simulink. Looking at example 2, we have a damper spring. The input is a position and the output is a position. And what we want is a transfer function, so I rewrote that on example 5. Or this one, anyway, on page 37. So it's bs over bs plus k. So I highly recommend that you save what you've done so far and call this question 1. I'm just going to take a shortcut and change this. So it's bs. Now b is 0.3. B is 0.3, x is 1, k is 2. So no great changes. So it's 0.3s. So in that case, I would put 0.3. Now, if I didn't have a space and a 0, that would just be 0.3 on its own. If I put the 0 in there, it's powers of s. So that's s to the 0, and this is s to the 1. So if I do that, we've got 0.3s over 0.3s plus 2. So you can see that we have 0.3s over 0.3s plus 2, like that. Okay, let's run that. Now this time, remember we've solved for input of x and an output of y. So it's not force, it's distance, but that's just because the transfer function is in that way. And what we've got after 1 second, we've got a sudden impulse of x has moved quickly, and what happens is this system recovers fairly quickly. So let's have a reminder of what it looks like. There it is. So this example 2. So x moves quickly, which moves the whole system because the damper acts like a very stiff rod, because this moves instantaneously, compresses the spring, but then once it's reached a steady position, the damper then slowly recovers and allows the spring to stretch back to its original length, which is what you can see here. And what this system is doing is, if you had a pointer on, it's actually showing you the rate of change of x. The faster x moves, the faster, the further this pointer will move across. And since x is stationary, then the pointer returns back to 0. Okay.